The top view of a line capital PQ is 70 mm and front view is 60 mm. The NQ is nearer to both HP and VP than the NP and is 15 mm above HP and 20 mm in front of VP. Draw the projections of the line if the distance between the end projectors is 50 mm. So here, the NQ is nearer to both HP and VP is 15 mm above HP. So when you look from the front view, you can see the distance above HP. So that distance can be seen in the vertical plane, which is Q dash, and 20 mm in front of VP. So when you look from the top view, we can see the distance in front of VP. The distance, when you look from the top view, that image will going to be seen in HP, which is small q. So this distance is 20 mm in front of VP. So you got the first point. Then the distance between the, draw the projections if the of the line if the distance between the end projectors is 50 mm. So from this vertical projector, because when you look from the front view, we can see the distance between the end projectors in the vertical plane. So you draw a vertical line, and also when you look from the top view, we can see the distance between the end projectors. The distance is seen in the horizontal plane also. Then draw a vertical projector here. Then the top view of a line capital PQ is 70 mm. So from Q, you cut an arc on this end projector to get 70 mm here, and similarly front view 60 mm. You will going to get this. So you have the P dash and you have P. So when this is projected and when this is projected, so you're going to get this line, which is QP. This is the line which is in space. Now we need to find out the true length in the vertical plane. When you want to find out the true length in the vertical plane, so you have to make the line parallel to VP. With Q as center, by taking the line which is QP, you rotate it such that it is made parallel to VP. You can see here, this is the line which is made parallel to VP. So that P1 and Q, capital Q, both are in front of VP by 20 mm. So when you look from the top view, that image will going to be here. So when you look from the top view, that QP is the one which is rotated and make it parallel to VP, QP1. Once you get this parallel to VP, so you are getting the true length in the vertical plane. So when you look from the front view, that image will going to fall on the vertical plane here. So this will be Q dash and P1 dash. So now we got the locus of Q here. So already, because of the P dash, which is already there, you are going to get it on the locus of P. Now, similarly, when you look from the top view, now we need to find out the true length in the horizontal plane. With Q as center, by rotating the QP, such that both Q and P2 will be above HP by 15 mm. So when you look from the front view, you can see that image with Q dash as center, Q dash P dash as the radius. When it is rotated and make it parallel, both Q dash and P2 dash is the line which is parallel to HP, so which is 15 mm above HP, and P2 dash is also above HP by 15 mm. So when this line is parallel to HP, so you are getting the true length in the horizontal plane, which is here Q and P2. So this is how, and the inclination made by this with respect to VP is phi, that is the true inclination, and the true inclination with respect to HP is theta, and apparent inclination with respect to HP is alpha, and apparent inclination with respect to VP is beta. So this is how you will be able to analyze this problem in 3 dimensions. Now we are going to take up by this first step by step. So here, when we have the line Q and P, because we know the distance between the end projectors is 50 mm, and here also the distance between the end projectors is 50 mm. So you got the front view and top view. When you project this line here, and when you project front view point P dash, both will going to intersect at this point. So you're going to get small QP, capital QP. So when you want to find out the true length in the vertical plane, with Q as center, you rotate the line QP such that make that P1 is also in front of VP by 20 mm. So QP1 is the line which is parallel to VP. So when it is projected, you will going to get the true length in the vertical plane. So the angle made by this will be theta. So that means when you look from the top view, so this is the one which will going to be the image which is rotated in the top view and make it parallel. So the inclination made by that with respect to HP is theta. So similarly, when you are seeing in the orthographic view of this also, we can see that 15 mm and 20 mm, and we know the distance between the end projectors, and you know the top view and you know the front view. So with Q as center, QP as the radius, you rotate it, make it parallel. So QP1 is the line which is parallel to VP. So you're getting the true length in the vertical plane. So the inclination made by that will going to be theta. Similarly, if you want to find out the true length in HP, you make that same line, that is QP, make it parallel to VP. So when you make it parallel to HP, so you're getting the true length in HP here. So how? So when you look from the front view, that Q dash P dash is the one which is the image which will going to be rotated, such that the Q dash P2 dash is above HP by 15 mm. So once this line is parallel to HP, its corresponding top view will going to be in the true length. So that is what you have the small q P2. So this is how you will be able to analyze this in 3D in step by step. If you are looking in the orthographic view also, you can see that the front view line is made parallel. So when Q dash P2 dash is above HP by 15 mm, so that line is parallel to HP. So you are getting the true length in the horizontal plane. When it is projected, you can say that QP2 is the line which is the true length with respect to HP. So the inclination made by that line with respect to VP is phi, and the inclination made with respect to the top view, which is beta. So this is how you will be able to analyze this in 3 dimensions. Now, and the orthographic view. Now we will going to solve this by using the sketchbook. So to do that, first we will going to draw the XY line and mark XY and VP HP. The NQ is nearer to both HP and VP than the NP and is 15 mm above HP and 20 mm in front of VP. As we know, it is 15 mm above HP. Above HP is seen in the vertical plane. So from the XY line, you measure 15 mm and draw a horizontal line which is parallel to XY. Similarly, 20 mm in front of VP. So in front of VP, distance can be seen in the horizontal plane. So that image, since HP is below XY line, from XY line you measure 20 mm and draw a horizontal line which is parallel to XY with a thin line. Consider any point and draw a vertical projector so that it will going to cut both the lines here, that Q dash and small q. Then we know that the distance between the end projectors is 50 mm. Once you have one projector here, that is the projector Q, and the projector P will have, which is at a distance of 50 mm. So from the projector Q, you measure 50 mm and draw one more vertical projector with a thin line. Then you know that the top view of the line capital PQ is 70 mm. So by using the compass, you measure 70 mm and with Q as center, cut an arc on this end projector line so that you will going to get this point small p, and then draw a dash dot line, and this will going to be the locus of P in the top view, and you mark this point as P and join Q to P with a dark line. And also the front view is 60 mm. So by using the compass, you measure a distance of 60 with Q dash as center, cut an arc on this end projector line so that you will going to get this point P dash, then join Q dash P dash with a dark line and draw a horizontal dash dot line and write this as the locus of P. Now we know to find out the true length in the vertical plane with Q as center. By using the compass, you draw an arc by taking the radius of QP and draw a smooth arc such that Q and P1 both will be on the same line. So that P1 is also in front of EP by 20 mm. So you mark this point as small p1. Then from here you draw a vertical projector to the front view wherein it will going to cut the locus of P in the front view. So you mark this point as P1 dash. As you know, QP1 is the line which is parallel to VP. So you're getting the true length. So you mark that as small capital P and capital Q in bracket. Then join Q dash P1 dash with little bit thicker than the XY line. Similarly, we need to find out the true length in the horizontal plane with Q dash as center. By taking the radius of Q dash P dash, you draw an arc such that it made Q dash P2 dash is the line which is made parallel to XY line in the front view. That is, Q dash is above HP by 15 mm and P2 dash is also above HP by 15 mm. Once this line is parallel to XY in the front view, then you draw a vertical projector from P2 dash to the locus of P in the top view, such that it will going to cut the locus of P in the top view and mark this point as small p2. As we know that Q dash P2 dash is the line which is parallel to XY in the front view, its corresponding top view, QP2 will be in true length. So join Q and P2 with little bit thicker than the XY line. So then, and Draw and mark this as capital Q and capital P in brackets. So this is how you will be able to solve this problem in the sketchbook and then show the dimensions of 15, 20, 50, 60 and 70 and the true inclination made with respect to HP as theta and with respect to VP as phi, and apparent inclination with respect to HP as alpha and with respect to VP as beta. So this is how you will be able to solve the problem.